Here is a function, a voltage function. What I want to do now is think about how we can use this integration to come up with something useful as for an engineer, to find an average voltage. Here is a function. The voltage in a circuit is given by a wave function. It's time dependent, so as time goes by the voltage is going to change, and it's given by this function, 3 sine 100 pi t. And you might remember, because we looked at wave functions, that this represents the amplitude of the wave and this bit represents the angular velocity of the wave. Who can remember the relationship between the angular velocity and the frequency? Omega equals you're thinking of the frequency as 1 over the period, and we're going to be using that in a second, but what does omega equal? Something f. 2 pi f, George. 2 pi f. And that's the angular velocity, is 2 pi. So I could work out the frequency, and you had to do something like that in assignment 4. So you could easily work out the frequency, just divide omega by 2 pi. So what is the frequency for this function? What is 100 pi divided by 2 pi? 50, thank you, Luke. So the frequency is 50. So what is the period of the wave? What's 1 over 50? 50 is into 1, 0, 50 is into 10, 0, 0.0, 50 is into 100, 2, so 0.02. Whoops. That would be the period of the complete wave, so this would be 0.0. No. The period is the period of the complete wave, which is this, isn't it? Carrying on up, certainly 0.01. Right. Let's say I wanted to know what's the average voltage for half a cycle. I've got a voltage that's going up to a peak of 3 volts. How do I know that's 3 volts? Because that's the amplitude, right. Guys, I know it's distractions going on, but just try and focus on here. We're nearly there, okay? The amplitude is 3. I've got a peak voltage of 3 volts, and it starts at 0, and then it's going up to 3 and back down to 0 again for half a cycle. What might be interesting to know for somebody working in electronics would be, well, what's the average voltage? If I could replace this by a steady voltage, what would that be? Because that would give me an idea of how much power I'm going to get out. So the average voltage is often a useful thing to find. How do I find the average? I find the area underneath this curve by integrating between 0 and 0.01, and then I divide by that distance, which is 0.01, and that will give me the average. And so that's exactly what I'm going to do. But how do I write it? I'm going to find the average. The average voltage, note the bar for average, the average voltage is going to equal the integral of the function, which is 3 sine 100 pi t with respect to t. But I need to find the area between the limits, which are 0 and 0.01. So that's how I find the area. Look at it and compare it with the sketch to see where it comes from. To find that area, I need to integrate it, which is what I'm saying here, between the limits of 0 and 0.01. But then I'm going to divide that by the distance, which is 0.01 minus 0, which is 0.01. So that's what I'm going to do. So the average voltage, right, let's do the integral. We need our table of standard integrals that you've got there. What's the integral of 3 sine 100 pi t? What happens to the 100 pi? And what happens to the sine? right becomes the cosine, sine becomes cosine or minus cosine? Minus cosine. So we've got minus 3 sine, cosine, 100 pi t, writing too quickly, but divided by what comes out and goes underneath, the 100 pi. Between 0 and 0.01. And then I'm going to divide that answer by 0.01. Now use the curly brackets and I replace t with 0.01. So 100 pi times 0.1 is just pi, 0.01 is just pi, over 100 pi. So that's the first one. Minus, and then I put naught in. So it's minus 3 cos of naught over 100 pi. Over 0.01. So if we work this through, we get 1.9 volts as the average voltage. Check by doing it yourself to see if you get the same answer. So what we're saying is the average voltage is 1.9 volts. So that's 3, about 1.9 volts will be back here somewhere. So in other words, that is our average voltage, 1.9 volts. We can use integration, in other words, to find average values.